Okay, so today we learned about how to determine if something is a function and a little bit about function notation and being able to figure out f of x on a particular function. So let's take a look at number one. Number one says determine whether each relation is a function and then state the domain and range. So remember, you're looking at the x values to determine if it's a function. If x repeats itself, then it is not a function. But if all of the x's are different, then it is a function. So in this particular case, we've got 1, 3, and 5, which are all different. So this is a function. And the domain is going to be the set of the x values, so 1, 3, and 5. And your range is going to be the set of the y values, so 2, 4, and 5. Domain is x, range is y. Number 2, if you look at the x values, you have a 3, a 3, a 4, and a 4. We definitely have repeaters, so this is not a function. Our domain is going to be 3 and 4. You do not have to write them duplicated. And then our range is going to be 4 and 5. Again, you don't have to duplicate, so just write 1, 4 and 1, 5. All right, 3 through 8, we are determining if something is a function or not. And this time, we don't have a table, we have an equation. So in class, we talked about the fact that x squared graphs are parabolas, and parabolas are functions because they pass the vertical line test. Y squared, on the other hand, gives us a side parabola. And side parabola, or a circle for that matter, if there's a y squared with an x squared. But y squared is never a function. So when you're looking at these equations, you can look at which one is squared. If x is squared, it's a function, if only x is squared. And if y is squared in the function, it is not a function, okay? So in number 3, we have a linear function. This is just y equals mx plus b, so this is yes, because all lines are functions. In number 4, we have x squared, which is a parabola, and parabolas are functions. They're those U-shaped graphs. In 5, we have a y squared. That y squared right there automatically tells me no. It's going to be a sideways type U or a circle for that one. And the vertical line test would not fit. Number 6, again, is a no because we have a y squared. Square root function. The square root function is like a v. So when we're looking at this, because this graph is not going to have 2 places where x will repeat itself, this is definitely a function. You can think of it in terms of the v-shaped graph, which vertical line test would pass, or you can think of it in terms of x values. When I put in an x value, I can put in any x value and it would still give me a y value. That's not repeating. Number 8, we have a y cubed. Now, y cubed means that this is going to be a cubed root graph. And a cubed root graph is a function. So on this particular function, you need to kind of think about what the shape of it's going to be. When you have a cubed root like this, the cubed root is going to look like this. And the reason I know it's a cubed root is because when you try to solve for y, to get y by itself, you're going to have to take the cubed root of both sides, which is going to become the cubed root of x minus 8, or negative x plus 8. Okay, number 9. 9, 10, 11, you're basically substituting in using function notation. Remember that inside the parentheses is your x value. So f of 6 means that wherever the x is in the function, and the function is 4x plus 5, wherever there's an x, we're going to put a 6. So this means 4 times 6 plus 5. That's 24 plus 5, which is 29. X plus 1 means 4 times x plus 1. You're going to put that in place of the x. And then plus 5. So when you distribute, you're going to get 4x plus 4, but you're going to add 5 to that, so it's going to end up becoming 4x plus 9. Putting in a negative x, you're going to do 4 times negative x plus 5. And so this is going to be negative 4x plus 5. Okay, number 10, we're going to put a negative 1 in wherever the x's are. So this is going to be negative 1 squared plus 2 times negative 1 plus 3. So that's going to be 1 minus 2 plus 3, which is going to be equal to 2. For the next one, it's going to be x plus 5 squared plus 2 times x plus 5 plus 3. So, x plus 5 squared, remember this is a binomial, so this becomes x squared plus 10x plus 25. And then this becomes 2x plus 10, and then you have the plus 3. So when you combine all your terms for this, you get x squared plus 12x plus 38. Okay, go back to remembering Algebra 2 when you learned how to square a binomial. So remember, x plus 5 squared means x plus 5 times x plus 5. So you're going to have to double distribute. All right, and then g of negative x is going to be negative x, not 1, negative x squared plus 2 times negative x plus 3. So negative x squared becomes positive x squared minus 2x plus 3. Okay, number 11. We're going to take the square root of negative 6 plus 6 and then add 3. Negative 6 plus 6 is 0, and the square root of 0 is 0. So that just becomes 3. This one becomes square root of 10 plus 6, and then plus 3, that's outside the radical. So the square root of 16 is 4, and then when you add 3, you get 7. And the last one, you take the square root of x minus 6, and then plus 6, and then plus 3. These are going to cancel, leaving you with just the square root of x, and then plus 3.